Okay, so let's have a look at question 9. So question 9, part A says factorise 4x squared minus 1. Now a lot of people, fine, absolutely fine with this. So we factorise it, we notice it's the difference of two squares. So it's 2x squared minus 1 squared, which means we're going to have 2x plus 1 times 2x minus 1. So that's the factorised form. So lots of people were okay with that. Some people didn't spot it, but you kind of know really what are the clues in the first question that says that's what I'm going to have to do. Ella?
4 is a square number.
4 is a square number.
X
X is squared.
1.
There's a subtraction. There's a 1. There's no common factor in either of them. There's only 2 bits. There's no x in the middle. All of these clues make you go, difference of 2 squares. Because they're not going to say factorise 3x squared minus 9. Why are they not going to give you that as a question?
Too easy?
No?
It doesn't work.
Oh, sorry. I'm going to change it. I've done that wrong. Let's do 3x squared minus 16. Why? Because I could have factorised that as 3. But, right, so this one does not factorise, and it does not do the difference of 2 squares because 3 is not a square number. So they're never going to give you that because they're not allowed to give you a question that says factorise this if you can't factorise this. They would say factorise this if possible, and you would have to know maybe possibility is an option, but they just tell you to factorise. So you know it can factorise, therefore take the clues. It's 4x squared minus 1. It's going to be the difference of 2 squares. Right, now the fact is that is a part A, and part B, okay, is now solve 4 over 2x plus 1. Oh, I've spotted something already. Okay, plus 1 over 4x squared minus 1, and that equals 3. Now I should, if I'm eagle-eyed or expecting these things to happen, know, oh look, that is the same as part A, and that is same as part of part A. Alright? So I would just, even if I didn't know whether it was going to be worth it or not, I'd just go 4 over 2x plus 1, and then I'm going to rewrite this with part A. So I've got 1 over 2x plus 1, 2x minus 1. There's got to be a reason why it was done like that.
I didn't even notice that.
But I tell you what, we did a question like this not a couple of lessons before.
Yeah.
And I said to you, you could either multiply by the whole thing, which would fine, but it will make it more complicated. There's a lot more stuff to it. Or what we then do is say, okay, well that, instead of that, well now all I need to do is multiply this one by 2x minus 1, top and bottom. Okay? Now my denominator's the same. However, what have I told you about fractions?
You didn't do it on the other side.
Everything has to have the same denominator. Therefore, this one has to be multiplied by 2x plus 1, 2x minus 1, over 2x plus 1, 2x minus 1. Now, there is another way of doing it. We did go through the other options, but this is kind of the way that I'm doing it with you, to kind of have the same process every time. Make every fraction the same denominator. It's just easier, right? Because now you see, if all the parts are the same, all the denominators are the same, all I need to consider are the tops. Yeah? Because the bottoms are the same, so I don't need to worry about them. So now I can just write that 4... Oh, wrong idea. I can now write that 4 lots of 2x minus 1 plus the 1 equals 3 lots of 2x plus 1 times 2x minus 1. Okay? Now, obviously, if you'd have multiplied everything by the 4x squared minus 1, you might still end up with the same thing, but with more stuff in it to cancel at the end. But you see how it's a lot easier to just have that one extra factor. And are you all happy about now kind of, I would say we are removing the, should we say, relevance of the denominator? Now, another way to think of it would be I've just multiplied everything by the denominator, all three parts, and that would get rid of it. Right? So that's another proper mathematical way to think of it. If I multiply by the denominator all three parts, that will cancel them out. Yeah. But I end up with this. All right. So that's quite an important stage. You have to be able to get to that. So what did people do wrong in their exam? Because on the whole, the first stage was all right. You multiplied through, you got the right denominators. Some of you struggled to expand brackets. One of you forgot to add the 1 on. We've had that chat. A lot of you that got so far forgot to do anything with the 3. Kind of just forgot to multiply it, or just forgot it even existed because you got so drawn into the left-hand side. Let's see, so you've got to keep it in mind what's going on. All right?
Wait a minute. Why did you write that then?
What do you mean, why did I write it?
Why did you write equals 3x?
Because I have to, because in the question it equals 3.
Hey.
I have to solve it. So one person, because they forgot the 3 that equals 3, they then, you don't mind it, then it turned into, well, the only thing I can actually be asked to do here is factorise this, because that's all I can do. But that's only because the equals 3 had suddenly disappeared. Right, what do we do now? Expand the brackets. 8x minus 4 plus 1 equals, well, actually I've got 4x squared minus 1 now, again, times 3, which is then, I've got 8x minus 3 equals 12x squared minus 3. I know one person got this far and then kind of got stuck. But if you have this mentality of moving things, suddenly it doesn't make an awful lot of sense. But if you think, right, now I need to eliminate things, well, I've got a minus 3 on each side. So if I actually add 3 to both sides, it gets rid of it. So now I'm left with 8x equals 12x squared. Yeah? Are you with me?
Mm-hmm. Yeah.
I have a what function? So I must
Make it equal 0.
make it equal 0. And how would I do that? I go 0 equals 12x squared minus 8x. Okay? How do you solve a quadratic equaling 0?
You missed that number.
What did I miss out?
Didn't you miss that?
No, I don't.
I thought a quadratic was 0.
No, it doesn't have to.
So it can be like minus 1 or something.
Yeah.
0.
Pardon?
Plus 0.
Yeah, it could be plus 0 if you want. We could have a plus 0. But not all quadratics have 3 parts. This would be a simpler one. It's quite a nice one to finish off, you know. If it had had a plus something on the end, I've then got to, it's a harder factorisation or a formula or a graphing. But actually this one, we still do what to try and solve a quadratic? Factorise. So shall we factorise it? What do we get?
4x.
4x times 3x.
Minus 2.
Okay. Now it might be a little bit off-putting that I haven't got 2 brackets, but the null factor law still applies. So either 4x equals 0, which means x equals 0. Yeah, it's the only way it can happen. Or 3x minus 2 equals 0, which means x equals
2 over 3.
2 over 3. So they're my 2 solutions.
Oh, that's so yeah, I thought it was so simple.
Yeah? So it's a long, complex question, But what do we take from it? Well, we have to be logical, patient, think it through, right? Take the clues from part A. Yeah? All of you went, oh, I didn't even spot that. Why do you think part A was part A?
I didn't get part A. Yeah, I didn't get part A either. So.
Well, yeah, if you can't do the part A, you're not going to spot it, I guess. All right.
I got it actually in the test. I think I got it.
Okay.
I didn't do it 8.
All right. Okay. Let's go back to question 8. Okay. So question 8. So we have root 12 minus 1 all over 2 minus root 3. Good. I'm glad you got annoyed.
Why do I know it? Because it's on the other test.
So you've had this question. Let me point this out again. You've had this question twice, maybe?
I did this question.
You've been told the answer to this question twice,
I got it.
if not more. So, Linnea, what do we do?
Well, first I FOILed. Well, no. First I multiplied both sides, both top and bottom, by 2 plus root 3.
Because we know if it's a surd question, something minus a surd, what are we using again?
Difference of 2 squares.
Difference of 2 squares. So you made the correct choice to start with and then made your life hard. So we know it's 2 plus root 3. And we do the same to the top. Now, Linnea, this is where you made life a little bit difficult. You foiled all this, which was great. It was correct. Absolutely no problem. But we kind of, if we know to do that, we are hoping that we would go, well, this bottom bit here is therefore 2 squared minus root 3 squared, which is then 4 minus 3. Yeah? Which is 1. Which you got to, but you foiled everything, and there's, you know, so it probably took you a few extra seconds than hopefully you'd need next time. All right? So we've got 1 on the bottom. Lovely, that's gone. Rationalised denominator. So then we've just got on the top root 12 minus 1 and 2 plus root 3. And we FOIL. So, Linnea, talk me through.
So 12 times, 2 times root 12 is 2 root 12.
Yeah.
Plus root 36.
So 3 times root 12 is
6.
So plus root 36 because of the 3 times 12.
And
but yeah, that is 6.
Minus 1 times 2 is negative 2. And then negative 1 times positive root 3 is negative root 3.
Negative root 3. So this is, I guess, that's the problem area for some people. So I've got 2 root 12 plus root 36 becomes 6. Minus 2 minus root 3. Collecting like terms, we've then got 2 root 12s minus root 3s. Got to do something with that. But plus 6 minus 2 is plus 4. So we've got 2 root 12 minus root 3. Okay. Now we have got to put it in the form 4 plus 3 root 3. That's what we need. We've got the 4. That bit's good. We just need to sort this out. So
then I looked at the question and I wanted root 3. So then I did 2 root 12 is the same as root 4 times 12.
4 times 3, sorry.
Oh, I just did the whole thing under, I did 2 squared is
Oh, okay. So
4.
you changed that to root 4.
Yeah.
I'll go with your method rather than what I was going to do, something simpler. But so you did 2 is root 4. So we've got root 4 times 12, so all of that, yeah.
And then that's 48.
So that's root 48.
And then I divided that by 3. And
Yeah.
16 times 3 is 48.
So that's root 16 times 3
and then that's 4 root 3 because 16 is a square number.
Yeah.
And then 4 root 3 minus root 3 is
So then we've
3
got
root
the
3.
minus root 3, minus root 3, minus root, follow it through. So then 4 root 3 minus root 3 is
3 root 3.
3 root 3. So then I've got the plus 4 to bring down, so I've got 3 root 3 plus 4.
You're a king.
Now I will point out an alternative. At this point here, what I would have done is said, instead of putting the 2 in, I'd have noticed that, well, 2 root 4 times 3, and root 4 is 2, so then it's 2 times root 3, which is 4 root 3. So I wouldn't have gone up to the 48 and then back down, but it was fine, absolutely fine. Okay? Any questions on that?
No.
No? Okay. One I would like to have a look at is 1.
Oh, yeah. I got that one.
Yeah, 1 and 2 actually. Question 1 and question 2. Yeah, lots of people got question 2 wrong actually. Okay. Let's so I can't wait for you to have a chat after all of them, before all of them. So Ying eats some yogurt. The yogurt contains 192 milligrams of calcium. This is 16%. So 192 is
question 1.
6. Yeah, this is question 1. Yeah, I said I was in question 1. Yeah. So that is 16% of the amount that they should eat each day. So that's the thing, 192 is 16%. Okay? So you need to figure out the 100%. Alright? So I would say something multiplied by 0.16, because that's 16%, equals 192. Because that's how you find 16% of something. So then I rearrange and do. So the amount equals 192 divided by 0.16, and you get the answer 1200.
I did it differently.
There are lots of different
I did
ways.
100 divided by 16 or something, and then got.
So what you could have done is say, well, if 192 equals 16%, if I do 192 divided by 16, I get 1%. So therefore I need to times by 100 to get 100%. So that would be 192 over 16 times 100
Also do that.
is another way. I'm sure there are lots of other ways to get around. Okay.
Mine takes so much easier. I don't know what I did.
Okay, if we don't have any questions, so question 2. Okay, I think people just got confused and didn't really read it and set it out properly. So it says, on the 1st of May 2012, the cost of 5 grams of gold was 14,000 rupees.
What are rupees?
It's Indian currency. The cost of gold decreased by 7.5% from 2012 to 2013. The fact that it's 1st of May is neither here nor there. That's just a year. Okay? So work out the cost of 20 grams of gold that year later. So first of all, right, I'm going to work, I mean there's lots of different ways around you could do this, but I want to know what 20 grams was. So I should multiply by 4. Okay? So that gives me 56,000. Lots of people didn't get that
I didn't.
in the question.
I got 4,000.
Yeah.
I just didn't divide.
Okay, yeah, alright. But now it says the cost of gold decreased by 7.5%. So I've got to apply a 7.5% decrease. Therefore, I'm going to multiply by 0.925, because a 7.5% decrease means find 92.5%. Okay? The other way to do it would have been 5,600 times 0.075 equals an answer, right? And then you would have done 56,000 minus that answer. Okay, and that would have been your final answer.
I took it away from the 14,000 roots.
Yes, because people did that because you didn't realise it was. Well, I think some people worked out the decrease on the 14,000, took it away, not realising that actually you've got 4 times as much as that. Okay. So, anyone, what's the right answer? 3? No, what's it? 5, 1.
8, 0, 0.
Okay. So that should be it. So you've got the 2 aspects to that. You've got the noticing I don't have 5, I've got 20, and you've got the applying a decrease. Okay? So that was, I guess, for me, if I were to say why I think a lot of you got that wrong, it was not reading the question thoroughly and really having a really good idea in your head of what it is you're actually doing and trying to solve. Yeah? Okay? Right. Any other particular question that you want to go through?
12.
12. Pardon? 10B, 12. Okay, let's do 10B then, to start with. So we've got, this one is easier than the other one we did. Alright, so, how do we rationalise the denominator when it's only got the root 2 on the bottom? Jonathan?
Multiply it by that.
Yeah, so you just multiply it by the same thing. It's much easier than when it's something minus or something plus. So then we have to do the same to the top. Okay. So then we've got 10 plus 3 root 2 times root 2 all over. Root 2 times root 2 is 2. So we've got that to start with. Okay. So now we just have to expand. So 10 root 2. So we've got 10 root 2. And again, this is where people have their issue. 3 root 2 times root 2 is
3 times 2.
3 times 2.
6.
6. All over 2. And now we've got 10 root 2s and 6. If we split that into 2, we end up with 5 root 2s add 3. So the 2 cancels with the 10 and the 6 to make 5 root 2 add 10. And that's your final answer.
That's unfortunate.
How did you get the 3 going?
How do I get the what? Because
It's over 2.
here, but how do I get the 3 gone, did you say? This 3.
Never mind.
But no, because this bit here, if I do that, I've got 3 times root 2 times root 2. So that is equal to 2. So then I've got 3 times 2 equals the...
Yeah,
6.
but we were dividing each number by 2, right?
Yeah.
Okay.
Yes.
Can you do 11C?
11C before 12B. Okay.
Oh, 12A and
I think Lanier was the only one to have a really good crack at the last question, actually. Right.
I got 1 mark for it.
Which one are we doing? 11C.
So, I mean, I'm pretty
I got 11C.
2/3 of y plus 3/8 of y equals 5. Adding fractions, what do you need to do? Denominator the same, so that would be this is 11C. So what's the, how could I make the denominators the same? What value? Yeah.
You're times it by, so that'll be 24? Is it? Yes.
Yes, Ella.
Oh, never mind.
Okay, so I've got y. So this would then be 16 and this would be 9. So I'm going to deal with that first and put them together. I get 25 over 24y equals 5. Because, remember we talked about this in class, I have 16/24 of y. I add another 9/24 of y and I have
A 5.
It's like if I got rid of that, you now wouldn't ask me why I've only got one y, would you?
I'm really upset.
Because it's 16 y's add 9 y's is 25 y's, but I've actually not got 16 and 9. I've got 16/24 and 9/24. So in total I have 25/24 of y. Okay? Now what do we do? So we've got 25 divided by 24y. A couple of ways. Yeah.
If it was a mixed number, could it be in one?
Yeah, I could do it as a mixed number. It'd be 1 and 1/24. I don't want to do that. I guess what we might need to be aware of, and I know we've talked about this before, 25 over 24y could be 25y over 24. Okay. All right. Now it might make more sense that if I times both sides by 24, I get 25y equals 120. I then divide through by 25, and I get 1y equals
4.8.
4.8. Or 4 and 4/5. Okay?
And 4/5 is 8.
4/5 is the 0.8, yeah.
Didn't we do that other number?
A minute ago, no? We did a question very, very, very similar to this in class, didn't we? I even remember standing here and doing one exactly like it, right here on the board.
No.
I
Not
remember doing
that long ago. I mean, like, didn't we just do something about that equals 4?
No.
Yes, Val.
Did we? No. Unless it was... Okay, let's... any questions on that? No? All right, so on the next one then, let's have a look at question 12. Okay. You're actually going to probably think, oh, right. There's several ways to do this. So here is a rectangle, but I'm going to think of it as... I'm going to block off...
A hexagon?
There's a rectangle. Do you know what? One person was like, what do you mean it's a hexagon? It's not a hexagon. It's rectangles. But how many sides does a hexagon have?
6.
How many sides does the blue shape have? 6. Therefore it's a hexagon. Okay. Did it confuse anyone? The whole it's a hexagon
It
thing?
says the area of the Well, I mean, it confused me, but I was so confused at this point, it didn't matter.
Right.
Yeah, me too, Jen.
So there is a very, I want to get through this, we've got 5 minutes, there's a very important aspect right at the end to this one. So I've got 4 up here, I've got 3x here, I've got 4x minus 3 here, and I've got x plus 1. So a lot of people have, yeah?
Isn't a hexagon a shape that has
6 sides.
equal sides?
No, that's a regular hexagon.
This is an irregular.
Right? Any shape with 6 sides. You might call this a concave hexagon. Alright. So, what we've got to do then, as normal, let's break it. This is what I think all of you tried to do. One way would be to work out the whole big one and subtract the small one. A lot of people broke it. Now, if you're going to do that, we then need to know these lengths. So this length is 4. So the area of this one is 4 times 3x, which is 12x. That was all right. This one here is x plus 1 times 4x minus 3 minus the 4. So this is 4x minus 7. Yeah? Because it's 4x minus 3 minus the 4 that is that bit, because that's 4, yeah? That was where a lot of people didn't twig. So then this one is that times 4x minus 7. So my area therefore is x plus 1 times 4x minus 7 plus 12x.
Where did this 12 come from?
4 times 3.
Oh. I did it.
Okay? So then we've got 4x squared plus 4x. What's that bit? And then we've got minus 7x and minus 7 plus 12x. That would be the area. So that, go on. So that gives me 4x squared minus 3x plus 12x is, so that's 16x. No, I'm confusing myself. 3x and 15x, yeah. 4x squared plus 15x and then minus 7. So that's the area, yeah?
How is 4 take away 7, 15?
But it gives me 4.
Oh, you did the 12. Okay, that makes sense.
Yeah, but it gives me another piece of information. The other piece of information it gives me in the question is that the area equals 40. So I've got 4x squared plus 15x minus 7 equals 40. So if I subtract the 40, I get the 4x squared plus 15x minus 47 equals 0. Something's wrong because I should have a 9x. Where did I go wrong?
You split the main term.
No, I don't need. I've collected something together wrong, haven't I?
Yeah.
Oh yeah, so that's minus 3 plus 12 should be 9. That's right.
Oh, then I wrote that.
Yeah, well, don't check it. We know it should be 9. These things happen, don't they? Okay. So I've got that. So I've shown how I got it. So this was the big problem that a lot of people had. Oh, that didn't work. Identifying that has to be done. Are you done? You're happy that you get the final bit, yeah? Oh, good. Right. Brilliant. I'm just noticing you're packing away, and I've still got a minute to go to do the important bit where a couple of people went wrong. So it says solve that. So when we solve it, how do you solve it?
Quadratic.
Wait,
So you're going to have. So that's part A. You're going to have to use the formula because it says give your answer to 3 significant figures. Now, what you get are 2 values for part B. If you use the formula, I'm not going to go through it. You end up with minus 4.73 or 2.48. Then it says find the length of the longest side. Now, one of those values of x cannot be used.
It cannot be the negative one.
It can't be the negative. So it has to be that one. So which side's the longest side? 3x. The 3x.
I said 4x.
Yes. People looked at the diagram and thought that looks longer.
Well,
Not accurately drawn. So it is fair. You are supposed to try it in that one and try it in that one. And if you tried it in this one, you get an answer of 7.44.
What if x goes
If you did it with that one, it was like 6.92. Okay? Alright? So this was the longest, and that's what it was looking for.
Would it ever be possible for like the smallest, like visibly drawn side to actually be the longest in a question? Like trying to trick you accurately drawn?
Well, I would say in this question, 3x is shorter. It says it covers itself. It's not accurately drawn.
Wait, I'm confused. What's the trick to that?
There's no trick.
Oh no, not the trick. No, I'm sorry. The little part that you said that we need to get. Why do I have to?
Oh, so up here, you were not doing the minus 4 bit to get that. And then even if you got these solutions, you were putting this value into that, assuming it was the longest. Okay?